All right, so yeah, my name is Áíne, and I'm going to talk to you today about motor capacities and concurrent motor interference and how they affect 12-month-olds' processing of others' goal-directed actions. So we'll get into what that actually means, that mouthful of a title, as well as what's going on with this young chap's little hands. So what this work is really about is about the perception-production link, right? Which is this idea that as we gain experience with a specific action, we then get better at encoding and predicting what other people will do when they're doing the same thing. So as developmentalists, we care about this because the ability to detect or predict someone's goal might be a sort of a building block for social development. And there is a lot of existing work out there that suggests there is a link. So one example of this huge literature comes from EEG research looking at desynchronization of the mu rhythm in infants, which is associated with action perception. And there's lots of work showing that as infants gain more experience with a specific action, they show changes in mu desynchronization when watching others, as they gain more competence, and also as they're trained to perform specific actions. And one sort of interesting motor milestone that people look at in this context is the development of the precision grip. So on the left, or on the right here, we have some images of different power and precision grips, a power grip being one that uses the palm. The precision grip, the gold standard, is then obviously the pincer grip, but before we get there, there's lots of other grips that use the interior surfaces of the fingers and thumb opposition. And there's plenty of work that shows differences between babies who can or cannot perform a precision grip in terms of how they encode other people's grasping actions, not just the shape of the hand, but also how it's used functionally. So I'm going to highlight some work from Meltzoff and colleagues from quite a while ago, but it's a nice simple paradigm in which they had 6- and 9-month-olds watching an action in which a hand reached behind an occluder. And the hand was either in sort of a wide aperture or a narrow aperture. The occluder they were shown two stimuli of the occluder having been removed, one of which the hand was in the same shape, grasping an object with that hand shape, the other of which they were grasping the object in a different orientation with a different hand shape. And the assumption is that the infants are going to look longer at the unexpected outcome. So that's the outcome in which the hand shape has changed. And indeed, that's what they found at 6 and 9 months. But what was additionally quite interesting was that they looked at a group of 6-month-olds and whether they could perform thumb opposition in their own grasping actions or not. And they found that this sort of preference for the unexpected object or the unexpected outcome at 6 months was related to the ability to form this kind of grip. So if we're thinking about what's changing this difference between the groups, what is it that this experience of action is actually doing to our action perception? There's a couple of different views, and again, there's like a wide theoretical literature on this, but one sort of general viewpoint is that we now have access to a motor representation of the action so that when we detect what's going on, we can access the end state of the action. But particularly with grasping actions, we'll see the end state of the action as we're performing it. We'll see our hand in the shape of around the object that we're picking up. So there's this sort of confound going on here. And there's also a viewpoint that the reason why action production changes action perception is to do with stronger visuomotor associations. And I'm just going to flag a really nice review from recent years by Gudrun Schwarzer and colleagues, where they went through a bunch of different mechanisms that might be underlying this. So it's not just going to be motor or visual mechanisms, it's likely to be a combination of things. But one thing that I noted in this sort of literature is that when we're talking about the effects of experience and we're looking at the action perception production link in infants, a lot of existing work is really looking at the constructive element of experience, right? So we're looking at what happens when the baby learns to do something new, when they learn to do something better, or when they get training on a specific action. So what I was interested in was coming at it from the other direction. So what happens if we take babies who can perform a specific action and we somehow interfere with their ability to perform that action? Does that have an effect on their encoding of someone else's action? So where I took inspiration from was sort of adult literature in which we know that if you change someone's hand posture, it affects their ability to use motor imagery. So a really core task that's used in this as like a very fundamental demonstration is the hand laterality task, right? So you're shown an image of a hand and you have to answer whether it's a right or a left hand, or as in this example, you're shown two hands and you have to determine if they're the same hand or if they're different hands. And there's a literature showing that when you put people's hands in an unusual position, so crossed behind their back is one example. Lucette Toussaint and colleagues do some really interesting stuff where they immobilize people's hands for like 24 hours before they take part in the study. When you do that, people become less accurate at this task and they become slower. But obviously this is a task that kind of invites the use of body imagery regardless, right? It sort of makes sense that you generate a mental representation of a hand and rotate that to match what you're looking at. So what about tasks that don't explicitly require motor imagery? And of course, action perception is one of these. There's lots of ways that we can, encode someone else's action and detect what they're going to do. So Ambrosini and colleagues, I know these images from their paper are kind of dark, but they essentially had two balls on a table in a video, small ball, large ball. They had an actor's hand reaching in either with a closed fist or with the hand shaped for the object that it was eventually going to touch. And they had participants looking at these images or looking at these videos using eye tracking to look at how early they got their gaze reached the target object. And what they found was that obviously when there's no hand shape, people are basically their gaze is arriving at the object at the same time as the hand, about 50 milliseconds before. But when the hand is actually shaped for the object that it's reaching for, so power grip shape for the large object, pincer grip for the small object, they're getting there about 200 milliseconds before the hand does, which is pretty typical. But when the participants' hands are constrained, there's a little bit of a slowdown. They're getting there before the hand does, but not that much earlier. So it suggests that this sort of posture manipulation is having an effect on their action perception. So in the current study, I wanted to take this approach looking at infant perception of action, right? So can we see can we do a sort of a motor interference paradigm with infants in the form of posture manipulation, and will it affect their perception of other people's grasping actions? So what we were doing was we were restricting the infant's ability to perform a thumb opposition grip. And we were also looking, because this is kind of early days, looking at whether the effect of interference is mediated by the infant's own general fine motor ability. So the paradigm itself, sort of somewhere between Daum and Ambrosini, we have a platform with a chute so that there's no reason for the actor's hand to go left or right too early and give these spatial cues. Hand reaches through the chute for a large or a small object. We title these the congruent and incongruent objects, right? So if the hand is in a large, wide shape, the large object is congruent, the small one is incongruent. If the hand's in a narrow shape, the small object is congruent, the large one is incongruent. And the action always ended successfully, right? So there were no mistakes, no errors. The actor always reached through and went for and picked up the object that matched the hand shape. But then, of course, this means that when we're analyzing, what we do is we cut off the period for analysis of where the infant is looking at sort of the last frame before the hand deviates to the right or the left, which would have been a couple of frames after the images here. And the posture manipulation, what we did, pretty simple, pretty low tech. We weren't going to do TMS on any babies. We got a little bit of sort of medically safe tape, and we tethered their thumb to their first two fingers. And then we put some little anti-scratch mittens over their hands so that they wouldn't tear it off with their teeth. This is the within subjects paradigm. So every infant got both conditions. So whether they did the hands-free condition where they watched the actions with their hands free, or whether they did the motor interference first, was counterbalanced. And I am surprised by this. I suppose we did enough piloting, so we should have known. But of 52 infants tested, only 4 didn't tolerate the taping and the mittens. They weren't all happy. There was a little bit of consternation. I had to become an expert kazoo player to do this. But they actually ended up, it was pretty successful. They were pretty happy to sit and watch the trials once the mittens and the tape were on. So we worked with 12-month-olds specifically because they should have a decent amount of experience with precision grasping by this age. We had an initial pilot of, we had a few pilots, but in terms of looking at the taping versus no taping, we had 15 infants, and we ran a power analysis off that, and then over-recruited because this is kind of a new approach. And this is sort of the pilot data. As you can see in the hands-free condition, the babies are looking more to the congruent than the incongruent object. But then when we restrict their hands, that difference in looking is attenuating. This is the pilot data, so it's pretty limited. And we also administered the early motor questionnaire to get a sort of a sense of the infant's own motor development. This is a motor questionnaire with 3 subscales on gross motor, fine motor, and perception action. So we had 3 core experimental factors. This was the motor interference, so whether the hands were free or restricted. The congruence of the object that was being looked at, so was it the congruent or the incongruent one, and the grip type that the adult was using. So were they using a small hand grip or a wide hand grip? And we also looked at the interactions with the EMQ subscales. Relatively complex model, but it fit pretty well. In terms of results, so we got that congruence by motor interference made a significant contribution to the model. We also found this for the other interactions, so congruence by grip type by the motor interference. But what everything hangs on, and nobody likes to get a four-way interaction, but that is kind of what we got, and that's kind of what things are hanging on. We've got this interaction between those three core experimental variables and the infant's fine motor score. So I'll go into a little bit more of what that means, but we didn't see any effects of the other motor scales, as you might have anticipated. So here's the data. What you can at least see initially is that on the left, for the power grip trials, there's really not much of anything going on. And I have some reasons why I think that is, and we can go into those in a moment. Things are kind of hinging on the precision grip trials. What we're seeing is that infants' parent-reported fine motor ability increases, so as we go further along that x-axis. They're showing a greater preference for looking at the congruent object over the incongruent object in the hands-free condition, and then that difference is kind of attenuating in that hands-restricted condition in the bottom right here. So there's a couple of caveats and considerations, and one is that we have these two objects that we showed them. We had a small object and we had a big object. And there was actually a pretty substantial effect of object size preference in that data. So we can't put object size and adult's grip type and congruence in the same model because it's overdetermined. But if we drop the adult's grip type and we include the object size, what we see is that they're just less interested overall in looking at the large object, which might be why in those congruent or in those power grip trials we don't really see any sort of congruent object effect, because they're really liking that small object and they're looking at it a lot. But in this sort of secondary model, we do see this effect of motor interference by congruence, and we do see that that then interacts with fine motor score. A couple of other caveats. Is this really motor interference? Probably have to get a measure of motor activation in order to determine that, but it's at least a start. And another question that sort of occurred to me was whether the infants were just distracted by the taping and the gloves. We found that in terms of their engagement with the trials, that didn't differ between motor interference and hands-free conditions, but we also thought about introducing an alternative taping control in which we had bigger, less restrictive gloves, and we taped the final three fingers so that they would still be able to represent this thumb opposition grip. In that case, we found that although babies were pretty good at tolerating one round of taping, not so good, not so happy when you come at them with it a second time. So we don't have too many infants for that. We'll have to see about whether we can do that as a sort of a between subjects paradigm. So we are seeing an effect of motor interference. It's kind of contingent on existing motor ability. There's a lot of things I'd like to do to feel confidence in this result, but there's definitely scope for future work with uniform objects, like Down's rotated cup, and also looking at things like additional effectors, legs, mouth, and additional actions. So, looking at cross-contamination, do we see an effect on kicking action perception when the hands are restricted, and vice versa? So I just want to say thank you for listening, and I hope I haven't kept you from your lunch for too long. And thank you to Andy Meltzoff, who was my sponsor on this project, and all of our colleagues who helped out, and of course the babies.
We have time for questions. While people are thinking, I might ask my own question. So my question is about, it's a general clarification question maybe. It's not even a developmental probably. So how about the actions that we are capable of but we haven't learned yet, like the complex ones? Do you think that the perception of them also might change? I was thinking about my dancing skills actually. So there are complicated moves that I'm not capable. And do you think that it kind of changed the way that I perceive them before being able to doing them?
So one thing I was actually thinking of including in this talk was some work with adults, because Emily Cross has a lovely study, I think from quite a while ago, where she had dancers who were trained dancers, and they were trained on specific action sequences, or just sort of, so by doing or just by watching. And there was, even though they would have all been capable of those movements, there was an enhancement for those who actually got to practice it motorically in terms of how they encoded it. In terms of predicting, I'm not sure, I think, there's different theoretical perspectives in the field. I think that there's sort of if we're thinking about the activation of a motor representation specifically, already having that in your repertoire is going to help.
Okay. Thanks. Thank you for the answer. Do we have any?
Yeah, thank you very much. I still processing what you said. So beautiful work, and fantastic idea about this, blocking the. And I was trying to pull out. There was work that Janet Werker did some years ago about so she was taking these kids and she was looking at, and this is the crucial thing, phonological perception of contrasts. And she put something in the tongue. I don't know if you know these studies, no? And what she found out is that the perception of the contrast was impaired when kids had the tongue blocked when they had to actually rehearse that kind of contrast, even if I think they are not able to reproduce this contrast. So there is this, and the issue and the question that I'm asking here is, what this kind of results, the Werker results suggested is that there is somewhat an influence over the very same concepts, if you want to put it that way, that you can perceive, that you can conceive in the moment in which you block the relevant motor action. And my question to you is, how much do you push your theory here? So what do you think is going on? Are you actually, because after all what you're doing is motor with motor, and the interesting part of the work of Janet Werker in this case was that she was really sort of going to a level in which you are already at the level of the representation, if you want to put it that way. I mean, there is a long discussion, but so what do you think is actually is the motor part contributing in terms of our conceptual repertoire? Are you pushing that theory that far?
So I am not pushing things particularly far for the simple reason that even those of us who maybe have like limb differences or motor difficulties, motor disabilities, that does not mean that people do not have social cognition or the ability to predict what someone else is doing. There are multiple pathways to this particular mechanism. So what I'm looking at is sort of, what is the role of motor interference? How much are we recruiting a motor representation, or indeed are we recruiting it at all when we're observing as infants, typically developing infants, watching someone else's action? Is this contributing to the process at all? And the fact that there is some interference suggests that there is a contribution. It doesn't mean that it's the only way to get there. It just means that for these typically developing infants, using that motor representation is, I don't think I have the strongest results in the world, but I think there's a start here. It's interfering with their access to that representation. It's not the only route to it.
Okay, so how about the non-typically developing infant? Because the question that we are asking here are very similar to questions that you can ask for. What can a blind child know about what happens in the world? And there is this long discussion that sort of seems to suggest that the child knows much more than you would expect if this was. So what would be your prediction? Take away this part, what is remaining in the conceptual representation of?
Well, it's based on sort of visual recognition of statistical patterns and of, conceptual associations. So I don't know the developmental speed of each of these routes and how they interact together, but that would be the alternative route. We do recognize things visually. We do have like a statistical model of these things. So.
We still have one time for one small question, if you have any. Is there? Yeah.
Thank you for the talk. I'm asking if it is possible to consider the age, different age before the emerging of the digital pans in babies and emerging period and well experienced. So to examine the impact of babies' own experience of different grasping hand, and so hand grasping, and especially the digital pencil.
Yeah, absolutely. I mean, this is where a lot of the previous work that looked at the sort of contributing effect of motor experience came in. I think we could absolutely try to do this with younger ages. I think what we might see in that case is that the fine motor ability makes a much bigger contribution, because you wouldn't, because of stimulus issues, we would have expected to see an overall very strong difference in congruent versus incongruent preference. We didn't see that here. Potentially, if that was fixed, we'd have stronger evidence that there's a congruence preference in the older ones. And then looking at younger infants, we might not see that, but it might be even more modulated by their own precision grip ability. It's quite a challenging paradigm as well, something I didn't flag. They've got 2 end states to look at and evaluate, or 2 potential end states, 2 targets. I think that's also why it became a little bit more of a complex paradigm for them.
Right, that was the end of the paper session, and we can have the lunch break. Thanks for Áíne Choisdealbha for the presentation.